Imagine a suit that fits you perfectly, doesn't wrinkle for years, repairs itself, is waterproof, has air conditioning and heating, and protects you against damage and radiation. And it's all for free. You're wearing it right now. This is your skin, or as they call it in Texas, your skin. Your skin consists of 3 layers: the epidermis, dermis, and hypodermis. Our journey begins with the epidermis. This is the uppermost layer of your skin. This is your personal waterproof armor that protects the body from bacteria and damage. The armor is equipped with keratin, the substance that makes hair and nails strong. The lifespan of this armor isn't long, but the old cells are completely replaced with new ones after 4 to 6 weeks. By the way, half of the dust found in your house is old skin cells. And they call me flaky. We also completely shed our skin. It happens so slowly that we don't notice it. If you watch this process in a time-lapse video, it would look like a shedding snake. But human skin is much larger than a snake's. If we spread it out, the average adult skin would be 22 feet square and weigh about 20 pounds, or about the size of a double blanket. The epidermis looks like a factory with endless cell conveyor belts. But this is not the only protection of the skin. Time to travel further and meet the immune warriors who live here, lymphocytes. They fight against bacteria and microbes that manage to get through the armor. Whoa, hey guys, we don't want any trouble, we're just looking around. Our journey goes deeper, to the epidermis bottom. The creation of your armor begins at this level. Here, the armor is soft and slowly rises to the top. We also notice cells that create melanin. People get skin color and tan because of melanin. But it's not only sunlight that can change the color of your skin. Your skin can be tinted orange if you eat a lot of carrots. But the coolest superpower of bottom epidermis is how it works like solar batteries. Thanks to this ability, the skin converts sun rays into vitamin D, which gives the body energy. We're going down to the dermis now, the second and thickest layer of skin. But the actual thickness depends on its location. The thickest skin is on your heels, the thinnest on your eyelids. We're traveling through skin on an arm, so we still have some traveling to do. It's slippery and wet here inside the dermis. The first thing we see are hammocks and elastic bands. We can jump on them like acrobats. These are 2 proteins, and thanks to them, our skin is elastic and stretches. One last jump, and we land near 2 forests. The first is a forest of nerves and receptors. Ow! Don't touch it, it's very sensitive. Nerves record the slightest touch, temperature changes, and send signals to the brain. The brain identifies these signals and makes you feel hurt, warm, cold, wet, dry, and even ticklish. So, if the skin is so sensitive, why can't you tickle yourself? Well, when we try this, our brain knows in advance which areas of skin will tickle. It also knows the strength and intensity of tickling. When we know this, the brain lowers the level of sensitivity. But when someone else tickles us, the brain increases the sensitivity, so the body responds quickly and defends itself. On to the second forest. It consists of hairs that look like huge trees. They grow everywhere. But it's not ground that keeps them rooted, but tiny muscles. When you're scared, get cold, or even listen to some awesome music, these muscles contract, making your hair stand up straight. There are many blood vessels in this area to control your body temperature. When you work hard at the gym, these vessels expand to cool you off. If you walk on the cold street and forget to wear warm clothes, your blood vessels tighten to keep as much warmth as it can. But if you run a marathon under the hot sun, look, your skin is releasing sweat from here. By the way, sweat actually doesn't have a smell. It only smells bad once it comes in contact with skin bacteria. Well, now that we've cooled down, time to go further. This level is so beautiful and fascinating. The structure of the whole skin depends on the dermis. It's like the foundation of any building. And of course, such a building requires additional security. The dermis has its own personal immune guardians, phagocytes, that fight against bacteria. Now, it may seem there's only bad bacteria around us, but we also have some friends too. They appear with the oil created by your glands. These bacteria help your immune system fight against bad microbes. Time to dive down to the deepest level of the skin, the hypodermis. It's very soft and greasy here because of fat. The fat is everywhere. But it's thanks to this fat that we can sit comfortably on our backsides. But this is not the only good function of fat. The body needs fat when we're hungry. The fat is used like a fuel and also soft protection for organs and muscles. But the coolest thing is fat produces the leptin hormone. After dinner, you feel full. It's not because your stomach is actually full, but because the leptin hormone tells you it is. That's right, fat controls your appetite, not your stomach. Let's say one small but very sneaky bacterium has managed to squeeze through and avoid the immunity warriors. Then it gets into the dermis, swims through the oil glands, walks through the hair forest, and runs away from the phagocytes to dive deep into the fat layer. The bacterium has passed all skin protection levels, and it's now going to infect the body. But not so fast. It gets in big trouble now. The hypodermis also has immune guardians called macrophages. These cells are created in the bone marrow. At the first alarm of trouble, this group of warriors arrives and destroys the uninvited guests. And now we're going to see the coolest skin feature of all, regeneration. When we get hurt, the wound is covered with a blood clot. This shell gets hard outside to protect the body from foreign organisms. Then microblasts appear inside the clot. These guys repair the wound with scar tissue. And the scar tissue is important here. Oh, by the way, these guys don't belong to a labor union, but they work anyway. That's why they're called scabs. Just a joke, really. Imagine a window in your house has broken. It started to pour rain outside, and you need to fix the problem. The best handyman in the city is busy right now, and you can't wait because rain is getting into your house. So you call a cheaper handyman who can replace the window very quickly. The house and the broken window are your skin with a small wound, and the rain is foreign bacteria. What is the cheaper handyman? Scar tissue. Ordinary skin consists of fibers going in every direction, but scar tissue has only parallel fibers. Fibroblasts use scar tissue because it's much faster for regeneration than ordinary fibers, and your wound needs a fast repair. That's why the skin on your scars looks a little different. And that's the skinny on how your skin works.